During the Renaissance, practitioners of the dubious chemical art of alchemy spoke of a substance capable of dissolving any other substance. Given the name alkahest, this fabled universal solvent could, among other things, purify agents of disease to heal the body. While today we know that no such substance actually exists, researchers are stretching the limits of the closest thing we have to a universal solvent: water. A recent study reports how introducing electromagnetic perturbations using metal nanoparticles can boost water's ability to bind to alcohols and dissolve hydrophobic substances. Liquid water is at once one of the most studied and least understood substances on Earth. That's partly because of the flexibility of the hydrogen bonds that connect individual water molecules to one another. For example, while we might expect water to become more viscous when confined to small spaces, studies have shown the opposite. Forcing water through the inside of a carbon nanotube can actually collapse bulky 3D clusters into thin 1D chains of molecules. But manipulating space isn't the only way to get water to behave in exciting new ways. In 2014, researchers showed that oscillating plasmas, or plasmons, delivered via metal nanoparticles could disturb water's 3D structure. These perturbations were found to reduce the number of hydrogen bonds shared between water molecules, leading to novel properties such as faster evaporation, delayed melting of ice, higher chemical potential. Now, the same team has shown that compared with normal deionized water, Plasmon-activated water can do a better job of binding to alcohols and dissolving hydrophobic substances. Separate experiments showed that disruption had another favorable effect, reducing the polarity of water molecules. That polarity is what normally makes it difficult to dissolve nonpolar or hydrophobic substances like oil in water. By reducing water's polarity through plasmon activation, the team found water could be made more lipophilic and could actually keep sunflower oil dissolved for longer than deionized water. These expanded properties of water were found to remain stable for up to 1 week. While that may not be enough for long-term use, it could be long enough to support at least some meaningful chemical reactions. And that's crucial. Performing chemistry without resorting to precious chemicals is an outstanding goal of modern chemical science. So while the elusive alkahest is likely to remain the stuff of myth, plasmon-activated water could very well be the solvent of the future.